Hey guys, welcome back to our next video. We are going to take a step further into the exciting world of stoichiometry and talk about gram to mole conversion and mole to grams. Now, you may be thinking, Mr. Lamb, we've already done this. We did this way back in Unit 2. This is pretty straightforward, and in a way it kind of is. The only difference is that instead of looking at one chemical, we're going to be converting between reactants and products of a balanced chemical equation. So there is a little bit more to this. You need to think about what we did last video when we talked about the mole ratio, and you guys will do just fine. Alright, so let's get going. Our learning targets for today are plain and simple. You will be able to convert between moles and grams, or grams and moles, in a chemical reaction. There are no new vocab terms for this, so if you tilt your head to the left 90 degrees, you will notice that I have put an equal sign and a close parentheses, indicating a smiley emoticon, because there are no key vocabulary terms for this video. Go ahead and laugh, and let's move on. Before we even get to this today, I'm going to go ahead and give you the secret word of the video, and the secret word of the video is iPhone. Make sure you indicate that in your notes. Alright, let's go ahead and get started. So we've already learned about how the mole ratio can help us convert between reactants and products in a balanced chemical equation. Now, keep in mind, if we can convert between moles of a substance, we can then use the molar mass, which we learned about last semester, to convert between grams and moles of a substance as well. So let's go ahead and dive into this and see what we are talking about. Alright, so here is our practice problem. Determine the amount of moles that are produced in both of the products with 654 grams of NH3 and excess oxygen. Now that word is important here. You'll learn more about what that means when we talk about limiting reactant problems, but for right now, when it says excess, it just means that there is enough oxygen for all of the NH3 to be able to react with it. We'll look at that more when we start talking about limiting reactant problems anyways. So the first thing we need to do here, obviously, is we need to go through and we need to balance this chemical equation. Now, you may have seen this one before. This one is a royal pain in the butt. So I'm going to kind of help you out with this just a little bit. We're going to put a 4 in front of NH3. We're going to put a 6 here. We're going to put a 4 here. And we're going to put a 5 right here. Now that is how you would go through and balance that chemical equation. Okay? It's definitely one of those ones that's a little bit trickier to go through and balance, but that's why I went ahead and did it for you pretty quickly. So keep in mind, you are responsible for knowing how to write out a chemical equation. They will not always be written to you like this. I may give you all of the things that occur, all the reactants and products. I may just give you reactants and ask you to predict the products. It's going to depend on the chemical reaction we look at, so keep those things in mind. All right, let's look at our problem. So it says here to determine the amount of moles that are produced of both products with 654 grams of NH3. So that's my given, is 654 grams of NH3. And what I need to do is determine the amount of moles that are produced of both products. So what I'm going to do is I'm going to start with 654 grams of NH3, and I'm going to have to convert to moles of NO and to moles of H2O. So how do we go about doing this? Well, let's go ahead and start with writing out our starting amount, which is 654 grams of NH3. Again, we're doing dimensional analysis, so grams of NH3 goes in the bottom of that step. Now, what's the only thing you can convert grams into? And the answer is moles. Remember, if we're trying to get NH3 into products, we have to get it into moles in order to do that. So we're going to start with grams, we're going to convert to moles. And then what we're going to do is we're going to use the mole ratio given by the balanced chemical equation above to convert moles of NH3 into moles of NO and moles of H2O. All right? So here we're going to have grams of NH3. We're going to have moles of NH3. Now the number when we go from grams to moles is always 1. The grams, where do we find that information? We go to our periodic table. Okay, nitrogen is 14.01, hydrogen is 1.01, and there are 3 of them. So the molar mass of NH3 17.04. Okay? Now we're not done yet. Remember, we want moles of our products, so I need another step. Whatever unit's on top of the previous step goes in the bottom of the next. And what I want is moles of one of my products. Let's go with NO to start off with. So we'll have mole of NO. Remember that these numbers here are given by the balanced chemical equation. So NH3 is a 4 and NO is a 4. So now that we have that, we just need to complete our math and solve for the problem. Making sure we use the correct number of significant figures. So we need 3. So this is going to be 38.4 moles of NO. All right? Now, again, the second part of the problem is converting that to H2O. So let's go ahead and do that. We're going to start with 600 grams of NH3. Grams goes on the bottom. And again, I'm going to convert that to moles of NH3, so the start of the problem is actually very similar. Again, not done yet. I've got it into moles of NH3. Now I need to get it to moles of water. So I'm going to have moles of NH3 on the bottom, and I'm going to convert that to moles of water. I look at my ratio, my balanced chemical equation. So we're going to have a 4 again at the bottom, but this time we're going to have a 6 on the top. Okay, and again, that comes from the balanced chemical equation, the coefficients in front. Same process. I just need to do some math and make sure that I have the correct number of significant figures in my answer. Again, I need 3 significant figures, so it's going to be 57.6 moles of water. Okay? Just like that. So you can see here, it's the same thing we did last time. We're just adding an extra step. So keep in mind, anytime you have moles, or anytime you're given grams, you always must convert grams into moles and then do your mole ratio. Or if it's asking for grams at the end, use the mole ratio to get it into the moles of what you want. And then the last step would be to convert that into grams. So again, this goes back to our dimensional analysis. This goes back to our ability to utilize and calculate the molar mass to be able to convert between grams and moles and utilize the mole ratio, which is what we talked about in our last video. So hopefully you have a really good idea of what we're looking for here. It's really not anything new. We're just adding an extra step to what we did previously. So now instead of just going from moles to moles, we can go from grams of one substance into moles of something else. Hopefully you're able to convert between moles and grams and moles in a chemical equation. So again, taking a look at our learning targets, hopefully you are able to convert between moles and grams or grams and moles in a chemical reaction. Like I said, guys, pretty easy stuff. Hopefully we will continue on this moving forward, and we'll talk to you guys next time. Have a great day, guys. Bye-bye.